Good afternoon. My name is Katerina Nikitina. Today I would like to present you my project, Could your heart rate indicate heart disease? As I looked at different data sets, this one from Cleveland grabbed my attention, as to me it seemed interesting to learn whether heart rate and heart disease are correlated, especially since heart disease is one of the leading causes of death for people across the globe. So statistical tests and models were performed to assess main factor of maximum heart rate during the physical exercises. Additionally, I added also age and gender to maximum heart rate to my second model in order to observe any abnormalities that could lead to heart disease. In the very beginning of my analysis, I plotted the main predictor, the maximum heart rate, to see the distribution of the data. It is normally distributed, with most patients reach heart rate between 120 and 180 during their physical activities. The lower maximum heart rates may indicate possible cardiac problems that I will discuss further. Next, I created a box plot of maximum heart rate and presence of heart disease. This box plot is very informative and useful, as a group with heart disease shows lower maximum heart rate on average at around 140, where compared to the group without heart disease at around 160 beats per minute. This difference of heart rate of 20 is large and statistically significant. We can see that people without heart disease tend to reach higher heart rates during their exercise, as it suggests that they have stronger cardiovascular performance. This plot of maximum heart rate versus age by heart disease, where heart disease is ranked between 0 and 4, where 0 means no disease, and from 1 to 4, it means the increasing severity of disease. From this plot, we can conclude the maximum heart rate and age show a negative correlation, as all the patients naturally reach lower maximum heart rate. At the same time, it is important to note that people with heart disease consistently have lower maximum heart rates during exercises, even at younger ages. Here we have box plots of maximum heart rate by gender, and also maximum heart rate by gender and versus gender by disease status. So from these box plots, we can conclude that both males and females show similar median maximum heart rates, roughly at around 150. And then the spread is slightly larger among males, indicating possibly more variation in their exercise performance. And then based on the other plot, where we have maximum heart rate versus gender by disease status, the tendency of lower heart rate and heart disease presence is again observed. As we can see, it's a negative decline. The correlation heat map of the key variables shows us the following, that the maximum heart rate is negatively correlated with age. And the other variables like resting blood pressure and cholesterol show mild positive relationships with age, which are natural cardiovascular aging patterns. So the maximum heart rate variable still remains an independent predictor, and I would say strong independent predictor. So doing my models, I created two logistic regression models. The first one was heart disease and maximum heart rate, and the second model was heart disease and maximum heart rate, age, and sex. The first model has strong negative relationship, so individuals who achieve higher heart rates during the exercise are significantly less likely to have heart disease. So this model alone captures a very good part of the pattern, since we can see that our predictive variable, which is the maximum heart rate, is statistically significant. The second model shows that the predictive variables are statistically significant, while age is exactly at p equals to 0.05. So heart rate variable is still an independent predictor even after accounting for other factors. The gender variable shows that males are around slightly higher than 4 times more likely to have heart disease compared to females. And age variable demonstrates that all the individuals have a slightly higher probability of heart disease. Also, it is worth noting that AIC score for the second model is slightly better. However, in my opinion, the AIC score for the first model is also pretty good. So I also produced the ROC curve to learn more about my model performance. And this ROC curve shows that the logistic regression model that I created with three variables performs well, three predictor variables performs well in distinguishing between patients with and patients without heart disease. So our area under the curve is 0.79. It's, of course, it's not perfect, it's not 1. However, it's nearly 8 out of 10 times model correctly classifies our patients. So this strong performance for a model was built, as I mentioned before, on three predictors: the maximum heart rate, the age, and the gender. Here I created a predicted probability of heart disease versus maximum heart rate plot. So the predicted probability plot shows that as the maximum heart rate during exercise increases, the likelihood of heart disease decreases. And this stays consistent throughout my analysis. This also suggests that individuals with better exercise tolerance, so basically the ones with higher maximum heart rate values, are less likely to have heart disease, which again proves throughout our analysis and stays consistent. And to sum it up, we can say that a lower maximum heart rate could indicate basically weakened cardiac function or poor cardiovascular endurance. And both factors are associated with heart disease. Also, patients whose maximum heart rates are higher during the physical activities likely have better cardiovascular responses versus the patients with lower maximum heart rates, which basically prove the opposite. And the model also confirms that the heart rate performance during the exercise, specifically the maximum heart rate, remains basically as a main predictor and one of the most reliable predictors of heart disease. And even after adding age and gender, it still remained the most significant one, as the p-value was lower than the other two predictors. That's